Okay, so this is where we left off. We just finished our constructor, so we're ready to go ahead and create our methods. And the first one we're going to do is the create topics method. So let's go ahead and define create topics. And here we can pass a lot of stuff. So the first thing it will be the topic names. Can be a list of string. The number of partitions. I'm gonna do it a default of 3. We'll do the replication factor. I'm gonna do it 1. Retention in milliseconds, that's going to be optional, one of these parameters. That's an int. Since it's optional, I'll put it to none. Cleanup policy. So you see that I'm adding a lot of stuff based on that documentation, and I can go through them later. The cleanup policy was just like how delete means we're removing old segments. There are other options like compact that are just keep the latest key version of that segment, so you can refer back to that documentation. We'll also do how many in-sync replicas we want. Like all of the acknowledgement conversation that we had. Say we have a cluster with 3 brokers. We want to have at least 1 replica in sync, not all of the 3 or all of them. Let's also use compression type, and we're gonna let the producer decide what's the compression type. Let the producer decide how he wants to compress the data before sending. And we can also do the maximum message bytes, but let's put this optional. Yeah, that is a lot of stuff. And this, what's going to return for us, a dictionary of a string and a boolean, which will basically say, returns me a dictionary that is going to map each of the topic name to the boolean, indicating whether the creation was successful or not. So you're going to have the topic and it was successful or not. I'm going to put the pass here. And now let's go ahead and build the topic config. So we can do the topic config. It's going to be an empty dictionary for now because we don't know what the user will pass here. So we're going to start with an empty dictionary. We're going to fill it based on the user arguments. So the first one, retention ms, that I can put it here. Okay, so if it's not none, we're going to just put the topic config, retention. Make sure you check the documentation so you know you are typing it correctly. The documentation from librd Kafka. And this basically says the retention in milliseconds. This is the retention period control of how long Kafka is going to keep the message before delete it. So you need to establish how long you want Kafka to keep the message before any deletions. Okay. Now, cleanup policy we have defined as well. If the user pass it out, then we have another config parameter, cleanup.policy. It's going to receive the cleanup policy. Cleanup policy defines whether or not Kafka will delete or compact the data beyond the retention window. So if the retention window expires, what's Kafka doing with that data? Is it going to delete it? Is going to compact it? So that's why we define this, and we're setting up default as delete. All right. Next one, what we can do compression type. So topic config, compression type. Again, all of these are available in the librd Kafka documentation, which are the configuration parameters. So compression type, it's going to control how the messages are compressed on disk. So there are plenty of options, and when we set it to producer, we're going to let the producer decide the setting when it's sending the message to the topic. Okay, so we're going to inherit that configuration. So let's move forward for the max message bytes. It's not none. And now we're going to use max message bytes. We need to pass this as a string. Okay, this is optional, so it's just useful to prevent oversized message from blocking the broker. So whenever you're sending a message that is too big, it might block the broker, and we don't want that. So we can control by using this parameter. Okay. Also, we do have the min in sync replicas. Topic config min in sync replicas. Also expected string. And this, as I told you before, the minimum number of in synchronization replicas that are required for a white to be acknowledged. So if you have 3 brokers, you want an acknowledgement whenever like at least one is written to one of the replicas. At least one of the replicas has the record written, then you acknowledge it back. That's what we're saying. Okay. So finally, next step will be for us to create our new topic. So as I mentioned, you see on the simple class, it's just the descriptor that is going to hold the metadata for each topic that we want to create. So this expects a new topic. And the topic is going to be T. The number of partitions is going to be num partitions. Replication factor. And then the config is going to be the topic config. There we just created. But we're doing like a list, right? So for every T inside the topic names, that's what it's doing. Okay. Remember the future conversation that we're sending requests to the broker, and we're returning dictionary of futures. Check back the previous video if you didn't see it. We're doing the same thing now. So we're going to do the futures, and now we're calling out the create topics. And we're passing our new topics. Okay, then the results of this is going to be a dictionary, just like we're saying. So let's create it empty. And let's loop through those dictionary futures to collect those results for each topic and future in the futures dictionary. We're going to try to get the result. We're going to wait for the topic creation result. If it fails, Kafka will throw an exception. Let's just log the result of it. So topic was created successfully, if that's the case. And we're going to say, since we're returning a dictionary for that specific topic, let's assign a true for that. Okay, we can have an exception. From Kafka exception, they're gonna say failed to create topic, and let's also throw out what is the error, and then we can assign false to this. Okay, take out the pass here. Now we should have a more complete create topics method for our wrapper class in our Kafka admin. And in the next video, we'll continue with another implementation.